Hello, everybody. I'm sorry that I couldn't be there today to help you guys through this first lesson in the second half of our triangles unit. You'll be getting this packet, by the way, that you see on my screen right now, these particular questions, when we come back on Monday. I just want to be able to give you guys an introduction and let you guys get some practice on this so that when it does come time for us to jump into our two-column proofs with statements and reasons again, that at least we'll have an idea of what it is that we're actually asking for, what kinds of things we're looking to show are congruent. Now, we've done this with congruent angles in our proofs before. Now we're going to be talking about entire shapes. Top definition you see here, we've already said two figures are congruent if they're the same size and the same shape. Great. But what that also means is that the individual pieces of each of those two congruent figures should also be congruent to one another. I know we've had corresponding angles in the past. Well, now we'll also have corresponding sides. They don't mean the same thing as when we had parallel lines. All it means is that they match. So that if we have two congruent figures, and you can see down in question number 1 here, we are talking about two triangles that I am told at the beginning are congruent. What we are allowed to now decide and determine based on what we see here is that if we have two congruent polygons, and this if and only if means it's going to work in both directions, two polygons are congruent if and only if all of their corresponding parts, every single side and every single angle in one triangle, or one entire polygon, it doesn't necessarily have to be a triangle, are congruent. That my angles in triangle ABC need to be congruent to my angles in triangle DEF, but in a very specific order. Luckily, if we have a statement like the one that we see here with triangle ABC is congruent to triangle DEF, and I'm asked, name the pairs of angles and sides using one from each triangle that must be congruent, this actually isn't going to be nearly as bad as you're thinking, because our congruence statement, if it is true, if triangle ABC is going to be congruent to DEF, then this statement alone already tells me what I need to know. That I see angle A right here in this corner of the triangle, or as the first letter in the triangle that's named, triangle ABC. And I know that angle A needs to have a congruent match in the other triangle. Lucky for us, if I have a congruent statement, all that means is, yeah, I'm using the first letter of the other triangle. We're not using the fact that, okay, these two triangles look alike, and maybe it looks like angle A and angle D are the same. I know this is true because the statement says so. And if I had specific numbers in each corner, like let's say I knew this was 60 degrees and I knew this was 60 degrees, then sure, I could say that they were the same. But I don't need that. I don't require that information when I'm going to go ahead and do this. So, great. I know that angles A and D have a match. But if these entire triangles are going to be the same as one another, I need every single piece to have a match. I'll go to my next letter, which is angle B. And I'll see that, yeah, it kind of makes sense that in the other triangle, I'm going to be talking about angle E. Process of elimination will give you the last one, but either way, if we have the congruent statement in front of our faces, if we can see, okay, triangle ABC is supposed to match with triangle DEF, awesome. That means anywhere I see an A, I should see a D in the other triangle. Anywhere I see a C, I should see an F in the other triangle. Cool. So that's pretty quick and easy, and if you guys can deal with it with the angles, then the sides are really not going to be that much different. The only difference with sides is that we use two letters to denote a side. One letter for each end of the line segment, each end point. Well, lucky for us, if we're just looking at a congruent statement right here, if I just pick any two letters that are next to one another in this triangle, like side AB, I'm going to go ahead and say, you know what? That side's got to have a particular match. And here's where things are going to get to be a little bit annoying. You guys can tell based on this drawing in the other triangle that DE is going to be the one that matches. That side, the one that connects your angle that's marked with one blue curve and two red curves in each of these triangles, they've got to be the same as one another. So it makes sense that the sides connecting those angles would be the same as one another. But now the order in which we give these letters does matter. Because if I'm going to say exactly that all of these pieces are the same, and I've already said that anywhere I see angle A, I need to have a match at angle D. Anywhere I see angle B, I need to have a match at angle E. That means I need to be consistent in the order in which I choose these letters. I am not allowed to say in this problem that line AB is congruent to line ED, because I would be going in a different order than was established in the first triangle. That's going to be the really annoying part about this, is that, yeah, it's now going to matter. Not when I pick my first shape. I could call this side BC, I could call this side CB. But then I just have to be sure that the other shape, when I go to this congruent statement and say BC is my second letter followed by my third letter, I need to make sure I'm matching to the correct side in the other shape. Again, the order that you provide these letters in does not matter. The last side here, let's go in reverse alphabetical order from C to A. Well, you guys can see this statement right over here to the left. Anywhere I see a C, I should see an F in my new matching triangle. Angle A is congruent to angle D, or third letter, first letter is congruent to third letter, first letter. It is a little annoying now that these angles, these sides, the order that we say these letters in is going to be important. And what I'm going to ask you guys to do based on just this section is to take a look in IXL. I'm going to be linking this, of course, in Classroom along with this video, where you are going to be asked about these congruent statements and corresponding parts. Now, we don't have a congruence statement for these two triangles, which triangle, for example, FGH is congruent to. What I do have is a measurement for literally every side and literally every angle. These select all that apply questions simply say, great, if any of these happen to match, then go ahead and select it. And if I look over here in my corners, I can see, oh yeah, I've got angle F is my first choice. Is that going to match with angle V? Sure looks like it. So yeah, I'd go ahead and say that's got to be true. And then I'll just keep going through. I'll just keep on saying, you know what, now let me go and look at my next piece. Is angle H the same as angle X? They're both 43 degrees, so yep, they sure are. GH and WX. GH is 37 yards. WX is 37 yards. Hey, great. Those two things match. Or, if you want to be even more specific, line GH connects an angle that is 60 degrees to an angle that is 43 degrees. Line WX connects an angle that is 60 degrees to an angle that is 43 degrees. So we do have that same match. And as it turns out, for this particular question, when we go to our last one and ask, hey, is triangle or angle G congruent to angle W? They both got 60s in them. Yeah, these select all that apply questions, you can totally have all four of them be right. That's fine. These kind of questions, however, you just have to be very careful about the order that you will say these letters. Yes, these two triangles are the same. Triangle LMK is going to be congruent to the other one I see here. But the important thing that we have to recognize and note is how we're going to put those letters in this triangle. Now you'll notice, in my first triangle here, I've got angle L, M, and then K. So the last letter that comes in this triangle is angle K. Well, that's the angle that's different, so that's going to be a good way for us to determine, oh wait, if I see 120 degrees for my angle K, I see 120 degrees for my angle Y, that means in this new congruent triangle that I'm going to say, Y has got to be the last letter. I have no choice. So no matter what, this thing's going to end with a Y. If I could draw a Y on this app, it would not be helpful. So yeah, my triangle is going to end with a Y. I just need to figure out the order of the other letters. For an isosceles triangle like this, though, where you have two angles that match, it doesn't matter. Angle L is 30 degrees and connects a side that is 19 feet to a side that is 32 feet. Notice in the other triangle, both angles W and X have that same property, connecting a side that is 19 with an angle or side that is 32. So thankfully for this question, it actually doesn't matter, but we do just want to make sure that we're typing it in some means. That Y needs to be the last letter. If it's literally anywhere else, this question won't be correct. You'll continue to get things more and more like this. Some of these cases, yes, you have the option to do this in multiple ways. Not sure why that drew, but whatever. Now I'm looking at this pair of rectangles. Doesn't matter if they're not triangles. I can still say, okay, these two pieces, they've got to be the same. I know that for a rectangle, if I know it's 37 on the bottom, then it's also going to be 37 on the top. Writing in IXL is hard. So that means if I'm going to say, all right, I have rectangle NMLK. Well, here's my NM to begin that rectangle. Whatever angle, or whatever side rather, I pick to match with that needs to be 37 meters long. And right away I can see how that's going to work for me. So since the other sides don't particularly matter, I can go ahead and say this in whatever order I'd like. VW, and then, well, I just have to make sure I continue going through in the correct order. I don't want to say VWYX, because that implies that I'm able to connect angle W directly to angle Y. So the order, again, is going to be important in these ways. As you get through more of these questions, you'll start to see a lot of repeats, a lot of ideas, but your goal is always the same. If you're given two congruent shapes, go ahead and tell me what are those pieces that are going to match up. And, again, selecting all of the ones that you see, that would match up. CD is 44 feet. GH is 41 feet. Sorry, not an option. And I'll just continue going through every single other pair. EC and IG, they're different. EC is very short. GI is very long. Angle E and angle I? No, angle E is 90 degrees. Angle I is not. And so you'll find some select all that apply questions where only one of them's right. I'm going to ask you guys to go ahead and try your best, again, as usual, to get an 85 on each of these sections of IXL. Here is one of them. We're going to talk about a couple of other things in the other videos I'm attaching. So good luck with this section, and once you're done, once you feel confident, we're going to move on to the next one, which will start to talk a little bit about our triangle congruence properties, how to prove just with information that two triangles are the same. But this is a good stepping stone to make sure, at least when we start naming these things and using the proper order of our letters, that we're getting things to match up the way they should.